At the moment, nobody wants to use hydraulics in wind turbines for the transmission because they would produce a lot less electricity per year. But by being able to match the efficiency of the mechanical gearbox, we can install hydraulics into the drivetrain. So we get all the benefits from the hydraulics, which are robustness, low weight, and also therefore low cost, without the disadvantage of the low efficiency, which is traditionally associated with hydraulic transmissions.
This gives us much better performance because it's in the nature of a hydraulic or a hydrostatic transmission we use the word decouple. It sort of separates the two problems. The first problem is how you capture energy, the most energy from the rotor as it turns, and the second problem is how you turn the electrical generator at a higher speed and in the smoothest way, so you get the kind of, if we like, smoothest, the cleanest electricity coming out of it.
The wind drives the propeller, producing torque at its shaft. This drives a pump instead of a gearbox, produces fluid power, pressure and flow in a hydraulic circuit, which in turn drives a hydraulic motor whose displacement is smaller than the pump, so is able to drive the generator at a constant high speed. The whole system is continuously controlled and monitored by a computer.
Its roots came from work that we did in wave energy starting probably in the late 70s. When we needed to find a way of conveying the energy from ocean waves, which are slow, irregular, have very high force, to the regular rotation of an electrical generator. And that, in fact, is very much parallel to what we're doing with the wind turbine.
What you have to imagine is that inside this machine here, there are many cylinders with pistons moving in them. And as the shaft goes around, we call it a ring cam because there's actually a cam inside there. So each time the shaft goes around, each of those 68 cylinders does a pumping stroke. With digital displacement, we can decide just when the pumping stroke is about to start pumping, we can say, well, do we actually want this to pump, or is it needed? Maybe we're working way down at part load at 10% of the full rating. If that's the case, then the computer will automatically disable that cylinder by controlling the valve at just the right moment. It just returns the flow, the oil, back to the low pressure reservoir. And we call that idling. And that's a really key part of it because a cylinder that's idling has got very, very low losses indeed. And that's a major contribution to the much higher part load efficiency.
We're releasing the part of the machine that you aren't needing at any one time, and in a way that it's not costing you much in terms of ongoing power consumption, whereas conventional hydraulics are spectacularly poor on that front, which is one reason that they haven't taken over all the different applications that they could have otherwise done.
This is a very large hydraulic motor, digital displacement. The idea is to have one of these pumps driven by the wind turbine rotor and driving two of these. Maybe the wind speed is only 6 or 7 meters per second, which is quite low for a wind turbine. We can turn one of these off. So we only have one generator, and that immediately reduces the losses even further.
It could, in principle, be applied at any area where you want to transmit shaft power. So we see that there are many applications beyond the wind turbine.
These include harnessing wave power, and Artemis has developed a car where the gearbox has been replaced with a hydraulic pump, which, via pipes, drives two independent hydraulic motors. It's shown around 50% savings in some circumstances.
With this carbon trust-funded program, we've been able to go from a paper study, which people believed, industry being able to believe in, but couldn't really pick up from, to a real hardware demonstrator.
The Carbon Trust is able, I think, to see that there is merit in supporting technologies perhaps at an earlier stage. And they've supported us 2 times, basically on the same technology, but at different stages in the development. And it has been extremely helpful to have their support early on. They've helped us with introductions. They've helped us raise our profile by inviting us to speak at various conferences. You know, perhaps some of these things are more hidden or less obvious, but there have been some very significant benefits. The financial community needs to know what their exit is, and they need to know that they can somehow reap some benefit within 4 or 5 year time frame, and the Carbon Trust isn't using that metric. And that metric is actually very difficult to apply, particularly in the renewables, because, well, I once joked when I was in my early 20s that we'd be doing this when we were old men, and now I'm 54, and we're still doing it.